Hi everyone, this is a introduction to the LLVM intermediate representation. So what is this intermediate representation? This is a language that is used in between what you program, that is the programming language that you use. It can be C++, Julia, and among others. Rust also is included. And so it is a strongly typed system, and also it has two forms of representation. One named a bit code, that is a binary form, and also has a textual form. And a very special property is that it is written in the SSA form. So it will have some implications on the way that it is programmed, that it's in a kind of theoretical way, and it is most interesting for compiler engineers, but we will see it later. So what we have to take into account is what kind of optimizations we want on a compiler. We want to search for the many kinds of optimizations, such as dead code eliminations, to allocate the space on the registers that we are using on the machine, and so on. So we want to optimize to that, and also to get optimal code generation for various platforms, not only the CPU, but also GPU and accelerators. So here is the a very basic program of LLVM IR. As we can see, there is a do nothing function, and that returns byte. And we can see that it's kind of verbose because we have to specify the return type, and always we have to specify the parameter types of what we are handling of. And how we can emit this IR. So we can use Clang flags or Brass flags or any compiler that uses as a backend LLVM. So we can set these flags and we can emit some LLVM IR. Another quite interesting thing that is a sigil, that is just another name for a prefix. So we have like global or local variables that are scoped by or prefixed with a pound sign, another with a dollar sign. As we see here, with a percentage sign. So here we have a square function, and we just do x times x, and as you can see, there is the type of the multiplication. There is an integer of 32 bits. These are the basic types. You can do aggregates that are like structs, and you can do different kind of aggregates, vector types, but these are the basic ones. Some basic arithmetic operations that you can represent. This is a more complex code, and here what is the most important thing to understand is the SSA form, because you have in this line where is the BR word, you have a 5 function. So it will look at runtime or magically which path you took to reach that loop start. So if you reach it loop start from the start tag that is above the loop start, so it will take the first path that is like the exit or the other one. And if you reach the loop start from the loop, so you will be redirected to the other loops. Well, it is other. It is on the inverse side. In that way, you can get a pow function to get x pow y. And I don't know if we have enough time, but these examples will be posted. And is how can you get a LLVM intermediate representation with Godbolt? that will be applying the flags that I showed you earlier. And to summarize all where you can get into LLVM, so you can go to the Kaleidoscope tutorial and also to inspect the documentations, the IR passes, and the community that is very active on Discord and Discourse. And also there are plenty of tutorials on LLVM.